Control systems operate in the real time, right? For the most part. You're controlling a motor, you're controlling a pump, you're controlling electrical grids. Those things happen in real time. So the protocols that are used in those systems, the way those systems are designed, they don't have security built in. Like, it's not like you can have an encrypted link between your SCADA system and the breakers and things that it's controlling, because that stuff happens in real time, and it has to happen in real time. Encryption takes time, right? So the protocols aren't designed to be secure; they're designed to work fast. They're not designed for what's called confidentiality, right? Because the data that runs in industrial control systems is not really good a few milliseconds later, right? It's good for right now. So to defend those systems, you have to think about it a little differently. You have to instrument and look for things a little bit different than what you're going to look for in a normal environment, right? So you have to put networking monitoring and all those other things in place to watch, but you have to be very, very careful. If you're trying to look for vulnerabilities in an industrial control system, and you fire off like a NESA scan, something like that, you're probably going to bring that control system down, right? It's not designed to do those sorts of things. So it just takes a different methodology, a different thinking towards defending those type of operations. They are very, very vulnerable, right? So the problem that we've had in that type of sector is, it used to be just, hey, let's just air gap that stuff off, right? So let's disconnect it from the internet and just not have it connected, and we'll maintain it internally and those sorts of things, that's a good approach. I mean, it's not foolproof, but it's definitely a much harder target when you do those sorts of things. The problem comes in is those systems today need to be connected to the internet. We have less operators, right? So people are doing things remotely. So they're trying to run those systems and maintain those systems not being on site. They have regulatory obligations, like to the EPA and things like that, where they have to report in data at a certain time. They get fined if they don't. So they have to have those things connected at all times to get that kind of business data out to keep the operation running. So that facilitates connecting these things in some way, in some fashion, to the internet. And if there's one connection, that's all an adversary really needs. So this is why, in the ramifications from a successful attack, again, life safety, much, much worse than a ransomware attack. Again, I'm not going to belittle the fact that someone gets ransomware and their business has to close, but people can die from a successful cyber attack against a water plant or any other industrial control system type facility.